but I hope this one will work. So, all right, so we got a piecewise function here, but it's got some unknowns in it. It's got this A and this B that I don't know. And so the question is to find the values of A and B, so the function, so that f of x is continuous and differentiable. All right, so that's what we want to do. Okay, so the way I do these problems is the first thing I do is, okay, I focus on the continuity. So in order for the function to be continuous, I have to have that the limit as x goes to 1 from the left of f of x is equal to the limit as x goes to 1 from the right of f of x. Oh, yeah. So, and I should comment real quick. I should say, I'm going to be focusing all my attention on 1, because 1, that's the place where the function changes personalities. So this function is going to be nice and continuous every place less than, wait a minute. Oh, wait, I have my inequalities mixed. Oh, no, that's fine. It doesn't matter. So as long as I stay on one side of the number 1, everything is nice and continuous, because this is a nice continuous function and this is a nice continuous function. But it's what happens at that transition point that things could go wrong. So that's why I only have to worry about what happens at 1. So all right, so let's look at the limit as x goes to 1 from the left. Okay, so if I'm on the left, then if x is left of 1, then I need to use the quadratic function. So this is going to be the limit as x goes to 1 from the left of bx squared plus x minus 2. Because I'm using this second function because that's the function that applies when x is on the left of -1. Because that's this negative sign means on the left. And then, okay, and then this one I can evaluate. I can just do direct substitution. Just plug in wherever you see an x, plug in 1. So if I plug in a 1 everywhere I see an x, I get b minus 1 because I'm going to have a +1 and a -2. So the limit as x goes to 1 from the left is b minus 1. But I also have to look at the limit as x goes to 1 from the right. And this time I'm going to use the linear function, because the linear function is the one that applies when x is bigger than 1. So I'll do here, this is going to be 3x plus a. And so to evaluate this limit, just wherever I see an x, I plug in a 1. So this will give me 3 plus a. So, all right, so the limit from the left of 1 is b minus 1. And the limit from the right of 1 is 3 plus a. And so to be continuous, these two things have to be the same. So I'll write that down. So to be continuous, we have to have that b minus 1 is equal to 3 plus a. Okay, so that's now we're not done. You know, we're not. That's good information. This is definitely good information, but it's not enough to finish the problem because again, it's a single equation with 2 unknowns. So this isn't enough. So I have to do some more work. And the second thing I'm going to do is I'm now going to do the same thing I just did, only I'm going to look at the derivatives this time. So I'm going to look at the limit as x goes to 1 from the left of the derivative of f of x. And I'm going to look at the limit as x goes to 1 from the right of the derivative of f of x. And the reason is that's what's going to tell me about differentiability, is that differentiability is about the derivative. So if you want your function to be differentiable, then you have to have that the derivative from the left is equal to the derivative from the right. So, all right, so let's see what these derivatives are. Okay, well, the derivative from the left, so when I'm on the left, I use the second function. And the derivative of that is going to be 2 times b times x. I hope that made sense. So where did that come from? Because the power rule says you bring the exponent down and you multiply, and then you drop the exponent by 1. So that's where that's coming from. And then plus x. Oh, but wait a minute, but the derivative of x is just 1, right? Because like the derivative of x is the same as the derivative of 1 multiplied by x, right? Because there's an invisible 1 there. And we know that the derivative of a constant times x is always just the constant. So the derivative of x is just equal to 1. And then, and then the derivative of -2 is 0, because -2 is a constant. So, all right, so there's your derivative of the left half. And then the derivative of the right half, okay, well, the derivative of 3x is just 3. And then, so, right, the derivative of 3x is just 3, because basically by the same constant multiple rule that we use down here. And the derivative of a, this one's a little bit tricky. You might say, well, what's the derivative of a? And well, remember, a is a constant. There's no x. There's no x here. So a is a variable, but for the purposes of our problem, we're thinking about it as a constant. So the point is the derivative of a is just 0, because a is just going to be some number. We don't know what the number is right now, but it's just going to be a fixed number. Whereas, and yeah, so, but I mean, I don't know, an easier way to think about it is if there's no x in it, then it's a constant, and the derivative of a constant is 0. All right, so anyway, well, this limit's easy because there's no x, so the limit of 3 is just going to be 3, because this 3 doesn't care what x is. And this limit, to find this limit, well, everywhere you see an x, I'm going to put in a 1. So this gives me 2b plus 1. All right, so we now know that to be differentiable, to be differentiable, we have to have that 2b plus 1 is equal to 3. Okay, so let me see here. I'll highlight these. So I have, what I have there is I have two equations with two unknowns. So I think I can solve those equations. I think I can solve that system. And in fact, yeah, let's focus on this one first, because this is the easier one. If I have 2b plus 1 is equal to 3, well, that's the same as saying 2 times b is equal to 2, and that means that b is equal to 1. All right, so we know that b has to be equal to 1. And now I can go over here to this equation. I can say, oh, in this one, I now know that b is equal to 1. So if I put b is equal to 1 into that equation, I get 1 minus 1 is equal to 3 plus a. So that means 0 is equal to 3 plus a. And that means that a is negative 3. And then I'm done. That was, I should say, I guess my final answer is that b has to be 1 and a has to be negative 3. So that's that. So anyway, so again, that I hope that seems very similar to the first one we did. Oh, I guess I can stop the video here.